Hello guys, can you all hear me well?
Why can't you stay organized?
I can't see myself, the ad is playing for me. Okay guys, how is it going? Hi. Is everything going well? Guys, I'm so sorry for the delay in starting this stream. There was some issue with the phone and it was not my camera in here was not showing. But now it's fixed. So, is everything going well? Let me also announce in the Telegram channel that this stream has been started. By the way guys, if you wanna join our Telegram channel to participate in the votes for the next topic stream, etc., you can use this link. Let me change my screen. You can use this link. Let me also say here the stream has started. This stream is started. You're talking in Arabic, I guess. I can't understand. What do you mean? Awesome. So, maybe we should wait a little bit till more of you join. Guys, did you have chance to participate in the contest? Let me zoom in so that we don't have the echo. Time is 11 p.m. in your country. In here is 11:56 a.m. You can also check Codeforces. Okay, everything is fine. Salam Matin. It's 9:26 p.m. in India. Okay, so it's a good time for you. 1 a.m. Where is 1 a.m.? I forgot where did you leave? SVSG. Oh, it was Korea, wasn't it? Yeah. Nice. Thank you, Arifin. I see. Yes, today we're gonna talk about recursion, talk about exactly what it is, and talk about some terminology about recursion. We will deep dive into this topic. 5:58 p.m. Where do you live, Mariam? Khaled. Guys, what is the time in all of your countries? For me, it's 11:57 a.m. Almost noon. Egypt. Nice. 21:27, 9:27. Can you say the best way to use your topic streams? Yes. I believe the best way is to, if you feel that you have some issues in some topics, you can hear, I won't zoom out so that you won't have issues with loading the page. Ukraine 1858. I see, nice. Eid Mubarak. For the topic streams, you can come here and you can see all the topic streams in here. So if you have some issues with some topics, for example, you have issues with number theory, you can watch that topic right away. But if you believe that you are the same level for all the topics, you don't have any priority on anything, and you want to grow in all of them without priority of learning this one first, then I believe it's good to start from the beginning and start learning. And the most important thing that I should tell you about watching these topic streams is to accept the problems that I discussed. For any of these topic streams, if you open them, if you come here, you can see the links to the problems that are solved in here. So you can just go to Codeforces and try to, after you completely understood the solutions, you can try to accept these problems. Okay. This was a bloody 8. Why? Did I find problems related to topics other than those discussed on streams? I can add more problems related to different topics. Okay. So maybe we should now start. Are you guys ready to start the topic stream today? There's the ads playing on my own screen. Okay. Audio quality is down today for me. Is audio fine for everyone? Oh, I see, Fahmi. I see. I hope that everything gets better. Okay. Not yet, but as I told yesterday in the Telegram channel, as I told you before, today I have started launching membership on this YouTube channel to try to extend the YouTube channel, and you can read the corresponding messages in Telegram. If you want, maybe during these topic streams I will talk more about it. But maybe for now it's better to start talking about the topic stream. Okay, so if you guys are all ready, let's start talking about the topic of today: recursion and backtrack. But membership is not supported in all countries. Really? For example, in which countries it's not supported? I didn't know that. That's interesting. I mean, that's not interesting, to be honest. I mean, that's bad. But are we only going to do chit chat? Pretty much. Usually in the live streams we do chit chats a lot. Maybe we should do this less often. Okay, let's start talking about the topic of today: recursion and backtrack. Guys, if you have seen other editorials or read something about it, or even the video that I have myself about recursion and backtrack, you can see that recursion, in one sentence, recursion means solving a problem using the smaller instances of the same problem. Using the smaller instances of the same problem. So what does that mean? Well, basically, you have seen recursive formulas, recursive functions. Can you give an example for recursive functions? Please discuss Eulerian path 2. Maybe we can talk about that. Like Fibonacci, Yes, or factorial, or things like that. For example, what is factorial? N factorial is the value of n factorial is equal to 1 times 2 times 3 times 2n. So basically, when we have a problem that is given us a value of n and it's asking us to find the value of n factorial, one thing that we can do is to just have a 4 from 1 to n and multiply this number and report the answer. But there's also another way that says that instead of doing all the work, let's use the smaller instances of the same problem to calculate the value. How does that work? We say that n factorial is basically equal to n times n minus 1 factorial. So if you want to calculate the factorials of numbers, use the exact same problem, use the answer to the smaller instances of the exact same problem to calculate it. How? For example, if you want to calculate n factorial, recursively calculate n minus 1 factorial. So you are using the answer to the same problem, but for a smaller instance. And multiply that by n. And that will give you n factorial. If we write it as a function, it will be like this. F of n equal to n times f of f sub n minus 1. So this is called a recursive function. A recursive function because it is recursing, it is using itself, it is getting back to itself. So that's how it works. That's what recursion means exactly. So if I want to, for example, code it in C++, as you all know, I write it very quickly. It would be something like this. You have int of, for example, n, it gets some int of f, I just named it f. Int of f, it's giving some n. And I say that for recursion, there's an important thing that we should always have in mind. There are basically two important things. One of them is the recursion. How does it recurse? The recursion itself. And one of them is the base case. We should also keep track of the base case. That we must have some foundation. We must have some base that we say that, okay, for this base, the answer is this. And for all the other values, the answer is calculated using this recursion. So for example, for calculating factorial, what can be our base case? Do you guys have any suggestion? Exactly, like n equal to 1 or n equal to 0. Yes, they both works. N equal to 1 or n equal to 0. So I prefer to use n equal to 0. I say that if n is equal to 0, return 1. There's no difference. I mean, if you never get input of 0, it makes no difference. Return 1. 0 factorial is 1. Why? Because it's the product of nothing. It's like the product of an empty set. And when you are talking about products, when you have an empty set, the value of it should be something that has no effect on product. For example, if it was sum, you should have returned 0. But since it's product, you should return 1. The product of an empty set is 1. This is how it works in all the formulas. So if n was equal to 0, return 1, otherwise return, and we're assuming that n gets a positive integer. I mean a non-negative integer. Otherwise, just return n times f of n minus 1. If n can be very large, you should also take it modulo some value of mod. But for now, we just stick to this. That we just return n times f of n minus 1. So this is how recursion can help us writes a code that works. I mean, the code can be written in a very more convenient and faster way. So we can define recursion to so many times simplify the solutions that we have. Another example that we have is, as you said, Fibonacci sequence. We have Fibonacci sequence. What is the definition of Fibonacci sequence? Can you guys help me with it? So this Fibonacci sequence is also a very famous sequence, and it's very important in mathematics and computer science. So Fibonacci sequence is, yes, exactly, the sum of the last two numbers, and it's very important. Fibonacci sequence. If in the future we have some streams about matrices, in there we also talk about Fibonacci as a very good example as well. Maybe in the future we can talk about that. Fibonacci sequence is a very famous sequence, is maybe the most famous sequence. It is like this. The first indices, I mean the index 0, fib of 0 is 0. Fib of 1 is 1. And for values greater than or equal to 1, greater than or equal to 2, fib of I is equal to fib of I minus 1 plus fib of I minus 2. So basically, if we write them from the index 0, it will be like this: 0, 1, 1, 2, 3, 5, 8, 13, and so on. It would be like this. So if we want to calculate Fibonacci sequence, we can again do the same thing. We can just say that int of, very similar to factorial, we can just say int of fib, int of n. And again, we have these base cases. I can say that if n less than or equal to 1, return n. This is the simplest way that I can write the base cases. If n was 0, return 0. If n was 1, return 1. So I say that if n was at most 1, return n. And Fibonacci sequence, yes, has different definitions. Sometimes people define it as starting from 1 and 1. Sometimes people start with 0 and 1. But the most conventional way to define Fibonacci is that fib of 0 is 0, fib of 1 is 1, fib of 2 is 1, 2. So if you start from index 1, it will start with 1 and 1, but if you start from index 0, it starts from 0 and 1. So just keep it in mind. In Fibonacci, the most conventional definition of Fibonacci is that fib of 0 is 0, fib of 1 is 1. Okay. Yes, that's exactly what we are doing. If n is equal to 0, we are returning 0, and yes, if it is 1, we are like returning 1. Otherwise, we will simply return f of fib of n minus 1 plus fib of n minus 2. That's all that we are doing here. And this way Fibonacci sequence can be calculated. There's also a problem that exactly is asking for the same thing on Codeforces. Maybe you can look at it here. I will send the link to you. It's in a Codeforces mashup. Maybe I can simply write the code for you in here too. It is Fibonacci of n. It will return 0 for 0, 1 for 1, and f of n minus 1 plus f of n minus 2. So maybe let me show the code to you here as well. It is problem O. It would be like this. Using namespace cd. I will define long of. I use long, maybe long, just to be cautious. Int of n, I will say that if n less than or equal to 1, return n, return fib of n minus 1 plus fib of n minus 2, int of main, and sin n, int of n, sin n, cout fib of n. That's how it works. I hope that this, without any memoization, this would work, because the problem itself wants us to use recursion, not DP. I hope that it really works here. Let's see that what happens. Is everything fine? Back in the time when we were preparing ourselves for ICPC, we had some challenge that we had to, this didn't work right now. We had to code in the editor of Codeforces without looking, and if we got a wrong answer, we should start all from the beginning. But here I copied the code so that it had some issue. It will, if it had some issue, it would work okay here. I mean, I can continue the code. So the definition, I think the index starts 1 before the indexing that I used. Let me bring the problem. I think the first, if n equal to 1, it's 0. If n equal to 2 is 1. So indexing is shifted only by 1. So let's say that if n greater than or equal to 2, return n minus 1 instead. I mean, the base case is changed. This way, if n was 1, it will return 0. If n was 2, it will return 1. So let's submit it again. And now it works. So basically, guys, in here the base case was different, and you see that sometimes Fibonacci in a problem is defined in another way, and most of the times we will calculate it ourselves. Most of the times we get the Fibonacci in somewhere. I mean, for example, I can tell you a problem that its solution is Fibonacci. You're not just supposed to calculate Fibonacci. You see that in a problem, the answer to this problem is Fibonacci. I will tell you a problem like this. So here it will work. In here, n equal to 1 returns 0, n equal to 2 returns 1. Otherwise, it will return fib of n minus 1 plus fib of n minus 2. And that's all. Is it clear? Bro, I have school tomorrow and time is currently 9:45, so please start quickly. What? Start what quickly? The topic stream is started. So what parts you want to be started? Is it clear, everything that I said so far? Well, basically we are in simpler parts of recursion. Yeah, if you mean that we get to harder parts, yeah, it takes time for that. No, I didn't understand. But basically it's calculating Fibonacci function. It's nothing special. Basically we want to calculate Fibonacci function. We say that for the base case, we return as it's defined. For the base case, you see that it's defined if n is equal to 1, return 0. If n is equal to 2, return 1. We have basically implemented what we have in here. Otherwise, we return fib of n minus 1 plus fib of n minus 2. And that's all. Okay. That's mostly going to be a future live stream, I believe. Okay. Yes, we will quickly move to more advanced. But I have to cover these parts first. Just so that's why f of 2 is 1. Yes, in this problem f of 2 is defined to be 1. But what is the issue with this? You know, if you look at factorials, you see that you have f of n. F of n calls f of n minus 1. I want to reach an important point here. And f of n minus 1 calls f of n minus 2. and f of n minus 2 calls f of n minus 3 and goes all the way to f of 0. This is how the values of f in factorial are being called. So basically we have n of n plus 1 function calls, which is good, which is okay. But in Fibonacci, there's an issue, and what is that? You know, if you see that how these functions are being called, you have fib of n here, and fib of n is calling fib of n minus 1 and fib of n minus 2. And fib of n minus 1 again is calling fib of n minus 2 and fib of n minus 1. Fib of n minus 2 here calls fib of n minus 3, fib of n minus 4. Fib of n minus 2 here again calls fib of n minus 3, fib of n minus 4, and so on. You see that what is the issue here, right? The issue is that we are calculating the same value over and over again. Fib of n minus 2 is being calculated here. Also fib of n minus 2 is being calculated here. This is n minus 3. And so on. There are so many values. Again, fib of n minus 3 is being calculated here and here and here. In all these places, fib of n minus 3 is being calculated. And for each one of them, we do the recursions again. We are calculating the values, all the values again. And this will get too large. Yes, a function can call itself. That is called a recursive function. A function that calls itself is called a function that calls itself. It's exactly what we are working with. It's a recursive function. So a function can call itself. That's a recursive function. So we see that there are so many times that we are calculating the same value. And how can we just, for small values of n it's okay. If n is up to 10, or even as we saw in this problem, if n is up to 30, it works. But when n gets large, for example, n becomes 10,000, this is going to be a very huge computation, going over all these branches and trying to calculate all of these values. This can be super complicated and it can take a lot of time. But what idea can be used? What do you think we can do to optimize it a little bit, and not a little bit, I mean, making a tiny change in the code, but making a significant effect on the efficiency of the code? What do you think we can do for that? Exactly. We do a trick named memoization. Hi Shannon, I just became a fast member, but I can't see the study plan of the month or other member. Yes. No, you should not do anything. The memberships, guys, for either any ones of you who have joined the memberships, it has been launched yesterday. So maybe you should just give it at the beginning on maybe 1 or 2 days. I think that until tomorrow, the things will be posted. For the second tier, there's a problem of the week that will be given to you, and for the third tier, there will be daily problems in a study plan for you guys, and it will be posted for you. Okay, so as you said, exactly, we do memoization. When we memorize that, what are the values, so that we don't calculate themselves again. So we do something named memoization. It's basically memorizing what we have calculated before. We say that when you calculate phi of n minus 1 plus phi of n minus 2, just store that in some array. Let's call it, let's show it with capital F of I. F of n, sorry, because we are working with variable n, f of n will be equal to phi of n minus 1 plus phi of n minus 2, and then we will return f of n. We store it in an array and we return that, and this way, the second time that we come to this function, we add another line here. We say that if f of n was not equal to 0, was greater than 0, it means that it has been changed, because initially they were all 0. If it was not 0, just return that instantly. So the point is, if you do this, phi of n will call phi of n minus 1 first, and that will call phi of n minus 2 and n minus 3, and so on. So in here, phi of n minus 2 will be calculated and stored in capital F of n minus 2. And the next time that in here we come to calculate phi of n minus 2, we see that it's been calculated, so we return that value right away, and we will skip all the calculations that we have to do here. So all these parts will be skipped. And it makes our code a lot faster, and you can show that again the number of function calls will be some multiple of n. It will be O of n. So by this simple idea, our code can get a lot faster. And an example of Fibonacci function, a problem related to Fibonacci function, is this. Assume that we have a tape with n cells. This is a very famous one. In everywhere we give this example. Even in the, if you have watched the DP topic stream, you can see this example. We have a tape of n cells, and each cell is either black and white. We don't want to have two adjacent black cells. How many ways do we have? You can say that answer of n, answer if we have a 1 by n, we have n cells in a tape, and we want to make some of them black. No two adjacent ones of them must be black at the same time. So we can't have adjacent blacks. Ans of n is either the last one is black. If the last one is black, the previous one must be white, because we don't have two adjacent blacks. And the rest, the n minus 2 rest, can be solved in any way. So it will be ans of n minus 2. If the last one is white, this first n minus 1 can be solved in any way. So it would be ans of n minus 1. And we see that this is exactly the Fibonacci function formula. So it gives us exactly the Fibonacci. This is an example that the problem can be reduced to Fibonacci number. Okay. So, is it clear so far or not? If it's clear, please use this emoji or put a plus or anything that you... the live stream is started 30 minutes ago, but I couldn't refresh. Oh, so that's why you were asking that. When does it start? Yeah, the stream has been started. Yeah, hopefully we get to the harder topics now. I mean, I covered the simpler topics so far, and now we are talking about some more advanced topics. Can you give us an example of hidden Fibonacci in a problem? This was exactly that. This problem that I just told you was exactly an example of hidden Fibonacci function in a problem. In the problem statement, you don't see anything related to Fibonacci. It's just about coloring a tape, coloring the cells of a tape. But there's a hidden Fibonacci formula behind it. And that's exactly what I said in here. We see that the formula is exactly Fibonacci sequence. If the last one is white, the next n minus 1 cells can be colored in any way. So ans of n will be reduced to ans of n minus 1. So if the last one is white, this n minus 1 can be colored any way they want. So it would be ans of n minus 1. If the last one is black, the previous one is white, and then these n minus 2 can be solved in any way that they have. So it would be ans of n minus 2. It recurs to smaller instances of the same problem. There's also a classic stair problem. Yes, we can also assume that we have n stairs. Each time we can go one stair up or 2 stairs up. And you can show that that will also be the Fibonacci function. Yes. So yeah, that was exactly the idea of memoization. What we did in here is called memoization, that we try to memorize that what are the values that we calculated, so that you don't calculate them once again in the future, and you don't go over all that computation once again in the future. You just do it once and save it once you calculate it, so that the next time you don't do everything all over from the beginning again. Just use the value that you have calculated before. So it's not that smart. I mean, it's very simple idea, but you see that it is so effective and it makes our code so faster. Just try it with n equal to 10,000, and if you don't add this line, even after 100 years you don't get the answer. After 100 years you can't get the answer, but just add this line and in less than a second you get the answer. Okay, so let's move on to the next thing. The coloring was basically making something, making some cells white, some cells black, such that we don't have any two consecutive black cells. And then we showed that if we have the last one black, the previous one is white, so we have ans of n minus 2. If the last one is white, we have the previous n minus 1s that can be colored in anything. So the number of ways that the last one is black is ans of n minus 2. The number of ways that the last one is white is ans of n minus 1. Okay, so now let's move on to the next thing that I want to say, and that's about recursion in general. Recursive problems are usually by themselves, they are not hard problems, they are very simple problems by themselves. They get complicated when they are used with something like dynamic programming or DFS or things like that. So recursive problems by themselves are not that difficult in general. When they are used with dynamic programming or DFS or things like that, then they get complicated. For example, even the tree traversal algorithms like DFS, you can see that they are also recursive functions. So basically they are the functions that are calling themselves. If you have seen the graph algorithms topic stream, you know that what DFS is. So DFS is that when you have a graph, consider we have some graph traversal algorithms like DFS, BFS, etc. DFS works like this. You have, when you run DFS on a vertex like V, first in this DFS you say that if this vertex was visited before, you will return because you have visited this vertex before. Otherwise, you will have a for on all the adjacent vertices of this vertex. To make it more precise, let me write the exact code. So int of u, g of v, we say that's DFS of u. So this is a traversal algorithm. It starts from a vertex in a graph, and then it looks at the neighbors of this vertex. And if they are not visited, I mean, it will call the DFS of those vertices. Assume that we have a graph, and we want to investigate it. We want to see each vertex of it. We want to investigate each vertex of it. We start from a vertex, we look at the neighbors, and go to that neighbors. If we see that it has been investigated before, we just return. Otherwise, again, from that vertex, you will see the neighbors and so on. This is also an example of a recursive function. And you see that a lot of times, these recursive ideas are used with ideas like DFS and dynamic programming and things like that. That's when these problems can get harder, that they can get some challenging a bit. Hi, Moonlight Wizard. And I see that some of you guys have been the members of the channel, have become the members of the channel. Thank you guys for your support. It really means a lot to me. I will talk a little bit more about the channel membership in the future, but first I wanna move on to the next topic. There's also another problem that you can solve in the same contest that I sent the previous problem from you. This contest in general, I saw that all of the problems that they have in here, they wanted to use recursion. So if you wanted, you can take a look at this link and accept these problems that you have here. You can. Most of the problems are easy. I mean, most of the problems in this recursion section are easy, and you can accept them all if you think that it's helpful for you. If it's easy for you, don't do that. So let's move on to the problems that, I mean, this was again another example of a problem that was using recursion. But now let's move on to the problems that I added to the contest. These were the hard problems and the challenging problems. I don't know how many of you guys have read these problems. This is when everything is getting challenging. You're still at University of Maryland because it's only 11 a.m. for you, but shouldn't you be at class? I'm at University of Maryland, yes, but no, I don't have a class today. I don't have that many classes. I have just 2 classes. You know, in PhD, you have just 2 classes per semester, and they are on Tuesday, Thursday. And to be honest, I usually don't attend them. There's a funny thing that in one of these classes, the professor was talking about me, and he was like, this guy Shayan never attends the class, never answers his email. I don't focus on my classes that much. I have more important things to do. Okay, so let's move on to the problems that we had in the contests, today. Did you guys have a chance to look at them? I think that today's contest was hard, relatively, for you guys. Yes, definitely. We can talk about how to generate subsets and permutations using recursion as well. Let me quickly say that as bad boy. Let's quickly say that as well. Assume that you have an array A1, A2 to AN. Okay, we want to find all the subsets. Let's say that, I mean, even for simplicity, let's say that we want to generate all the subsets of numbers from 1 to n. Using recursion, we want to calculate all the subsets of the numbers from 1 to n. How can we do that? Well, this is again something that we will do by going step by step and calling the same function that we have each time with the ways that we can go. I mean, recursion uses branching. So, I mean, we use branches. We say that, okay, in some ways we use one, the number 1 is in our subset. In some ways, 1 is not in our subset. And again, from here, in some ways, 2 is in our subset. In some ways, 2 is not in our subset. Again, in here, the same thing. In some ways, 2 is in our subsets. In some ways, 2 is not in our subset. And we can implement all these using a recursive function. So what I can do is this. I can just have, like, for example, let's say let's use it as a void of subsets, And I have a Boolean mark that shows that each number is in our subset or is not in our subset. This is I believe, the easiest way to implement this. And I say that what is the current number that I want to choose if I want it to be here or if I don't want it to be here. It's I, for example, I'm a number I. Initially, I'm a number 1. I decide about number 1. And I also keep number n, that what is the last number. I could also just keep the last number as well instead. I could also say that, let's say it this way might be better. Let's say that I have subsets and I'm on I. It means that I have to consider the subsets of the numbers from 1 to I. And when I consider the subsets of the numbers from 1 to I, what I should consider is this. What I should consider is this. I say that either I comes in my subset or does not come. First, consider all the cases that I is not in my subset. So, okay, about I, I'm sure that it's not in our subset. So basically, I should find all the subsets of 1 to I minus 1. So I said I talk about the base case at the end. So if I equal to 0, this is our base case, and I talk about it at the end. But for now, I will talk about this part. For now, I say that if I is not in my subset, I will set mark of I equal to false. This means that I is not going to be in my subset. And then I will recursively call the subsets of I minus 1. I said that, okay, recursively now find all the subsets of the first I minus 1 numbers. And so this is the cases where I is not in my subsets. And then I consider the cases where I is in our subsets. We have mark of I equal to true. We say that, okay, I is in our subset. Now find all the subsets of I minus 1. So we put I aside. We say that, okay, I is in our subset. So we put it aside. Now from the I minus 1 first elements, we find all the subsets of the first I minus 1 elements. So this is when I is in our subset. And in our base case, we just simply, for example, assume that we want to just simply output the values that we have. We're going to have a 4 of, now we use j from 1 to, let's say that we have the global value of n as well, which is the size of the subset that we want. We have a j from 1, j less than or equal to n, j plus plus. And we say that if mark of j, cout j space, and then cout \n or endl. Go to the next line. So basically, when we reach I equal to 0, we are going to have a 4 from 1 to n. We just cout all the ones that are marked. It's basically the ones that are going to come in our subsets. We should also say return here too, so that it will not run the rest of the code, the rest of the function. So if I is equal to 0, it will return just this. Otherwise, we set mark of I equal to false first, and then we find the subsets of the first I minus 1 elements, and then we set mark of I equal to true. We say that, okay, this one is in our subset, so we put it aside. Now solve for the first I minus 1. This is subsets. This is how you can find all the subsets of a sequence. This way you can easily find them all. Yes, this will output all the possible subsets of numbers 1 to n. Permutation is also like that. You can just simply say that you can have a 4 from 1 to n on each number. You know, you should just keep that which numbers are used. If a number is used, you set used of I equal to true. And then you will start going from the first index to the last one. On each number, on each position, assume that you have fixed the numbers here. On each position, you should decide which of unused numbers you want to put here. You choose the unused number that you want to put here and then put it here, and then call the rest. Set used of that one equal to true. For example, if you put x here, you set used of x equal to true. It means that x is used now. And then you will go for the rest. Yes, for the subsets, the complexity was of 2 to the power of n. And that's the best possible complexity, because the number of subsets itself is 2 to the power of n as well. Are you finding the subset of a set in this problem? Yes. I mean, the problem that I was talking about was the number, was all the subsets. We choose, for each number, we decide whether it is present or not in that subset, but we are doing it for all the possible subsets. I mean, at the end, if you run this code, it will have 2 to the power of n lines, and in each line, the numbers that are present in that permutations are outputted. So basically, yes, all of them are being outputted, all of the subsets. And you have chosen all the ways that some of these numbers are chosen. And in the subset, some of them are not. Is it clear? Can we optimize this function? This function, it can be shown that this function cannot be optimized. Why? Because we want to, in here, we want to output all the subsets. We want to output all the subsets. Okay. And we know that the number of subsets is 2 to the power of n by itself. So anyway, you have to at least output 2 to the power of n lines. So the order will be exponential. This time complexity is exponential, and it should be exponential. Because anyway, at the end of the day, you should output 2 to the power of n rows. So you cannot make it polynomial somehow. You cannot make it like O of n. You cannot do it with n operations. It's definitely, if it's n is 10,000, and you have to output all the subsets, in 100 years, this function cannot respond. And the fact is that you cannot do anything about it as well. You cannot optimize it like how we optimize Fibonacci. That can't be done. Yes, exactly. It has to be exponential. Exactly. Okay. Do you have any questions so far? If not, we can maybe now move on to the problems of the contest. As I said, maybe the contest today was hard. The problems, the difficulty of the problems are around 2000. But today I want you to show that how these 2000 problems, using the simple things that I just told you, can be solved. And they're not really hard. Please give some examples where we can use this. Use what? Use recursion. If you mean using recursion, now I'm gonna talk about the problems in Codeforces that you can solve. And they're around 2000 difficult. Okay, I-1 and I should be there. What do you mean? I didn't understand. Okay. Yeah, the difficulty of the problems were around 2000. This one is 2000. This one is 1900. This one is also 1900. All of them are around 2000. Yes, I will talk about backtracking as well, yes. And yes, I will show you examples as well. Guys, do you know that what is the main difference between backtracking and recursion? I mean, what is backtracking exactly? What is the term backtracking? yes, we go backwards. You know, there's also a famous thing named backtracking. What does backtracking do? It's basically want to solve some problem. It goes back and uses the values from the previous ones, similar to Fibonacci. How in Fibonacci, when we were calculating Fibonacci of n, we used Fibonacci of n minus 1, n minus 2, and so far, and so on. We calculated the previous values, right? We kept calculating the previous values, and we're going back. In backtracking and branching, one additional thing that you can do is that when you entered a path that you're sure that it doesn't work, you will return immediately, and you will not continue that anymore. For instance, DFS is kind of like a backtrack. Assume that we want to investigate a graph, as I said. There's something that we want to find in this graph. There's in some vertex, there's some drug, and we want to find that drug. We start from this vertex and we will call other vertices. We will call other vertices to investigate them. In backtracking, as I said, when we enter some states that we are sure that this state won't work, we will return immediately. We won't continue wasting our time on that one. In here you see that we have a line that says if vis of I is true, return. And I forgot to say after this that vis of v must be set to true. It means that if this vertex is investigated before, we have came here before, it means that this vertex is investigated, its neighbors are being called from before, and nothing is found. If something was found, we were reporting it. So there's no point in doing it again. In backtracking, the main idea is that when you are branching, considering the different cases, branching is also exactly what we see here. We are in some state, we will consider different cases that we can have. This is called branching. Again, from each of these, we'll consider the next states. When you reach a state that you are sure that it won't work, we will just return immediately. For example, assume that we want to find all the subsets of 1 to n such that no two consecutive elements are both in the subsets. We want to find the subsets, all the subsets such that from each two consecutive numbers, at most one of them is in the subsets. Maybe none of them, maybe one of them, but not both. What we can do is to do the same thing, but in here at the beginning, I can say that if mark of I plus 1 was true, you can just write mark of I. It means that if mark of I was true, and then mark of I plus 1, and then mark of I plus 2 was true, it means that both I plus 1 and I plus 2 are true. The mark of both of them are true. We can return immediately. It means that the last two numbers that we chose were both true, so this way definitely won't work. So we will get back immediately. We will cut off this branch. We know that this branch never reaches some answer. So that's also some important idea that we have in backtracking. Is it clear? What are you saying? Okay. If it's clear, please use the emojis again or the plus in the chat. And we see the examples of backtracking and recursion in the problems that I want to discuss. Okay, nice. Awesome, and thank you guys. Thank you. Okay, so now let's talk about the problems. So the first problem that I want to discuss is I think it's the best to start from, let's start from this problem, inandimo. In this problem, it says that Ina and Dima, let me send the link first to you guys. 374C. Sorry, I did not understand what are we doing exactly. I say it again very quickly. I just said that if we wanted to find out all the subsequences, that they do not have two consecutive numbers. I mean, from each two consecutive numbers, at most one. For example, the subset cannot have both 2 and 3. It cannot have both 5 and 6. From each two consecutive numbers, at most one of them should be in an array. I say that I will do the same thing that I did in here. Just at the beginning, I say that if mark of I and mark I plus 1 and mark of I plus 2 were both true, it means that both I plus 1 and I plus 2 are chosen. Both of the last two numbers are chosen in my subset. In this case, I will return immediately because I know that this branch will never reach to an answer that we want. So I cut it off at all and I won't continue. That's also an important idea that is used in backtracking. That as at the first time that you see that this branch will not work, you will just return immediately and you don't waste your time on that branch. That's also something that we have. And welcome Narit to join the problem solver. And thank you for the problem solver Tahir, and thank you for your support. Okay, so shall we now continue? Nice. If mark of I mean not equal to 0, if mark of I is true, it means that I is in our subsets. So if mark of I plus 1 and I plus 2 are both true, it means that both of these numbers are in our subsets. Definitely, sure, I'm more than happy to be able to help you. I read. It's okay, no worries. No worries. If you just want to support me, regardless of if you do or not, I mean, if you can't, I completely understand it, and that means a lot to me. I mean, if you support me, support our work, or you just want to support my work, but you can't for any reason. In both of the cases, I thank you guys. You guys are really amazing, and it really means a lot to me, to be honest. And I will tell you about the perks of each level. I mean, it's not something that you just pay for it and get nothing in response. That's not right. There are some perks that you will get in response, like the study plan, etc. I said in detail in the Telegram channel. You can see them here. But I will talk more about it later. For now, let's just focus on our topic stream. Oh, I see. It's okay. No problem. Okay. What could be the maximum size of array that can be taken? Imagine an array having infinite capacity if memory limit is 256 megabytes. Well, about the memory limit, I just tell you something to keep in mind. Guys, in general, just keep this in mind. 10 to the 6 integers, if you have an array of size 10 to the 6, is gonna be 4 megabytes. Why is that? Why 10 to the power of 6 integers is 4 megabytes? Can you say that how many bits each integer has? How many bits does an integer have? One int takes 4 bytes. Yeah, exactly. It has 32 to be more precise. Each integer has 32 bits. So there are 2 to the power of 32 integers, possible integers. And there are the numbers, the limits of integers is from minus 2 to the power of 31 to 2 to the power of 31 minus 1. These 2 to the power of 32 integers are possible. I mean, out of this, it's going to be out of integer man. So it's 32 bits each integer. And how many bytes is 32 bits? Each 8 bits is a byte. So when it is 32 bits, it means that it's 4 bytes. So each integer, one integer, is 4 bytes. So 1000 integer is 4 kilobytes. And 10 to the power of 6 integers is 4 megabytes. 10 to the power of 7 integers then is 40 megabytes. And 10 to the power of 8 integers is 400 megabytes. That's what you have in mind. So always you can just have this one in mind as the base case. And if you have more integers, just multiply that. For example, you multiply it by 10, 100. Just keep in mind that 10 to the power of 6 integers is 4 megabytes. Okay. In year 21 or 23. Because, why I left participating in Codeforces and solving problems, because I entered the next stages of my life. I mean, I started my PhD, I started working more often, I started doing many things. So I didn't have as much as time that I had in high school, so I couldn't participate. And that's why I believe that it's the most important thing for people to learn this very well when they have time. I'm more than happy that in high school I learned this, and I reached at least I reached to IGM in that time. And that's more than enough for me, because right now I get contacted by companies that offer me an interview, that I can interview them simply because I'm good at competitive programming, I'm good at mathematics, I'm good at algorithms, to say more precisely. Right now, competitive programming is very important for companies, because recently competitive programmers have performed well in different companies, and it's a very positive point right now. That, for example, if you are a grandmaster or an IGM, etc., companies consider that as a very good point. So they contact you and they offer interviews, etc. And I'm more than happy that I could do this around the time that I was in high school, and I used that time. But now I have more. I have more things on my shoulder that I have to focus on. So I couldn't continue. Hi Biswait, and welcome to the supporter tier. Thank you very much for your support. This will make CNC out faster. How good do we have to get in order for companies to ask us for interviewing? I believe when you get to Grandmaster or IGM, you get contacted, especially if you have an account on LinkedIn and mention that in your LinkedIn. There are companies who are actively looking to hire such people. I told you, recently competitive programming has become so important, and it's a very good news for us. When I started competitive programming, when I started Olympiad in informatics, I never knew that it's gonna be so important in the future. So I consider myself lucky, because I never knew that. I mean, almost everything that I earned in my life was because of competitive programming. Almost everything, even my admission to the university was because of that, mainly. So yeah, that's very good. So if you have time right now, try to focus on it, because maybe in the future you're gonna have to do more things and you have less time to focus on it. Okay, how much rating is enough to get gold medal in IA? There's no guarantee. We had an LGM that got a silver medal before. We had an LGM that got a silver medal, and we had a candidate master who won a gold medal. So there's no guarantee, but if I want to say something in average, I think maybe average is like being a grandmaster, So it's not a guarantee, as I said. You can be an LGM and not get a gold medal. You can be a candidate master and win a gold medal. It depends on the day how you participate in the contest. And Codeforces is a bit different than IOI, although there's a high correlation between the performance in Codeforces and IOI. There's a high correlation. Usually people who are better at Codeforces are better at IOI as well, and vice versa. There's a high correlation, but there are some differences too. So yes, we had LGM that was silver. It was a Chinese guy. It was in 2017. It was, I forgot his name. But I remember the IOI that year was in Iran, and I was in Iran too. IOI 2017, it was in Iran. I was in Iran too. There was a guy from China. I think his name was Matthew or something. He had a very high rating. Everyone were thinking that maybe he wins the first rank, but he won a silver at the end. Yeah, so, but I believe that maybe in average, if you're a grandmaster, being a grandmaster is almost like gold medal. Okay. Yeah, you cannot send the link, unfortunately. I tried to fix it in the settings, but I couldn't. So maybe you mean this block. IUI Codeforces. Maybe you mean this. Yes, there was this block. This was a good block that was talking about the correlation about the winning the gold medal and having a high rating on Codeforces. This is the plots that we have. So let me share this with you guys. Okay. Yeah. CP is a lot more important than IOI as an IOI. It's not only about IOI. It's even about your job interviews in the future. It's more than IOI, ICPC, everything. I mean, basically you can build your life right now with CP. I'm telling you, even my admission to the university, the main important thing in it was the awards that I got in competitive programming. I mean, for the medals and awards that I had in competitive programming, that was the most positive point in my resume and helped me to get admission here in the US. Okay, so let's move on to the next problem. I see. Let's see what happens. When is it too late? When is it too late? When you have a lot on your shoulder and you really can't find that much time. But still, it depends on your goal. For example, if you want to participate in IOI, entering the university is too late because then you cannot participate in IOI. Or when you want to participate in ICPC, when the age limit is passed, then you cannot. But for job interviews, you always have time. I see when people who are 35 years old and they are solving problems on LeetCode and even Codeforces, solve the same problems, DP problems, DFS problems, things like that, to get ready for job interviews. A lot of people who are learning competitive programming for job interviews. There are a lot of people who are doing that. So it depends on what is your goal. If you want to participate in IOI, entering the university is too late. But if you want a job interview, never is too late. Any time that you have time to get ready for job interviews, you can try to solve problems there and grow in that. I have not participated in so many LeetCode contests, but I guess so. I participated in 3 or 4 contests, LeetCode contests. But guys, I want to cover more LeetCode very soon as well. Maybe we can have some of the topic streams on LeetCode. What do you think of that? I mean, I'm gonna just continue this conversation for 2 more minutes and then we'll move on to the next CF problem. What do you think of that? Do you agree with this? Maybe some of the topic streams can be about lead code so that you guys, it can help you guys for some jobs in the future as well. No, there is no observations on lead code. It seems lead code have easy interface than CF. Good idea. This is nice. Yes. So we have. Okay. Most of you guys seem to be interested in that. I mean, at the end of the day, you should earn some money as well when you grow up. If you're in high school, and if you're already in the university, it's more important for you. I mean, you should think a little bit about landing jobs as well. So. Yeah, it's okay, Hamza. I mean, now you have the chance to get ready for job interviews. They are related. I mean, there's not much difference. I mean, if we solve lead code DP problems from lead code or Codeforces, there's not much difference. And yeah, the good news is that for people who are good at Codeforces and spend time on Codeforces, learning lead code and getting good on lead code is a lot easier because Codeforces is more focused on competitive programming. All people who are on lead code are not aware of Codeforces, but maybe we can cover more lead code in the future. So maybe our next topic streams can be more about lead code. Yes, definitely. We will cover that. For now, I highly recommend you to watch the topic streams and solve all the problems that I discussed. It really helps you to learn data structures and algorithms, like dynamic programming, graph algorithms, number theory, things like that. They are all important. How do competitive programmers who just do that earn money? Usually people use lead code a lot for that. I like Codeforces not just for Java, I'm just passionate about it. Yeah, that's also very good. If you're passionate about it, that's even the best motivation. Because if you're passionate about it, usually you grow more if you're passionate about it. But anyway, you have the chance to use it too for earning some money. And who hates money? If you hate money, give your money to me. Just distribute between everyone. Okay. So, yes, let's move on to the next problem. When will you teach some advanced algorithms? Right now in the topic stream, I want to solve these 2000 problems. How do people earn money using CP? I just told you, for example, if you are a grandmaster or an IGM in Codeforces and you have an account on LinkedIn, people will reach out to you. Companies usually reach out to you. Okay. That's completely okay. I mean, let me tell you this as well. I want to talk about the problem, but this is very important. Go to this part's guideline videos. Guys, that's more than important for you guys to watch all these 3 videos. Make sure to watch all these 3 videos. They are super important. I told you, I don't want to go over them right once again, just sorting the problems, solving from the easiest one, etc. I can say, but it's better if you just say that in the videos. See that in the videos, because I just said that already. It's more than important for you guys to watch them. Yes, time's up. Yeah, you're right. Okay, let's talk about this problem. In and Dima bought a table of size n by m in the shop. Each cell of the table contains a single letter D, I, M, and A. Let me send you the link again, because from the last time we went to... No, today is not Friday. And it's almost never right on Friday. It's Monday for me. So we have a table that's on each cell of it, there's either a D or an I or an M or an A. Each cell is one of these letters. And we want to start at some points and the starting point should be D. I mean the cell that we start from should be D, and we want to create the name Dima many times, as much as we can. And the process is like this. From each cell we can go to neighbor cells, and we want to create the word Dima. For example, if we are in D right now, the next time we have to go to the word I, and the next time we have to go to the word M, and the next time we have to go to the word A, and so on. Again, after A we have to go to D, then I, then M, then A, then again D, I, M, A, D, I, M, A, etc. So it's exactly like this. You have to say that what is the maximum number of Dimas that we can see. If it's 0, you should write pur Dima. If it's infinite, you can see it infinitely is pur Ina. Otherwise, you should say that exactly how many times it is. For example, in the first example, there's no way to create Dima. So we write pur Dima. We return pur Dima. In the second one, you can start from this D and go to I, and then M, then A, then D, I, M, A, D, I, M, A. We can just do this cycle infinite number of times. So the answer is infinite. So we write pur Ina. In this example, we can show that the answer is 4. I mean, let's see that how exactly it is. For example, maybe one case is to start from here and go down. Upper left corner, Ina can go through the name Dima 4 times. Yeah, for example, also, yeah, we can go from top left corner. This is 1 Dima. Then the second Dima can be like this. Then like this. Then like this. And it will be 4. So it would be like this. This. And then this. And then this. And then this. So the answer is 4. Is the statement completely clear? N and M are up to 1000. 2086C was the recursion problem recently on this. I see. Yeah, we all solved it now. If anyone has any issue with the problem statements, let me know. Otherwise, put a plus or use this emoji. It's a DFS. I mean a recursion on the table with some memoization as well. Okay, let's talk about it. So basically it's like this. Let me tell you about it. So we have this table and we want to create the name Dima. What I do is I want to find the answer from each of the cells. That is starting from this cell, how many Dimas I can see. And based on what the character is, it would make some small adjustments there too. For example, if the word is D, I should find out how many Dimas I have all over from the beginning, like this. But if it is an I assume that before it was a D. So I assume that there was a D before that as well. I just say that, okay, this D was here. And then comes from here, how many Dimas I have. So I say that, okay, this D at the beginning of Dima is given. Now what is the maximum answer? And if it was M, I say that, okay, D and I, we have it, we were on them right now. We take it for granted, and then we see that how many Dimas we can find that. And if it was A, we say that we assume that D and I and M, we have them before. And we see that how many Dimas do we have, and so on. So from each one of these cells, answer of I and J is gonna be, or let's say res of I and J, the result of I and J says that how many Dimas I can have starting from cell I and J. Okay. So yes, the most important thing in here is memoization. When I entered a cell and I see that its value of result, this cell is visited before and its value of result is calculated before. When that happens, I just return right away. And I will return the value of the results that we have there. So if that happened, I will just return that right away. So now the question is how to calculate these values. How to calculate these values of res of ij. How many ways are there to step on all cells of a rectangular grid? Exactly once. Okay, no, yes, let's move on this problem. I think, Sean, you are talking about the next problem, I guess. Okay, so we want to calculate this value of res of ing. The point is that when I am in some cell, I'm on, for example, I have void of calculate, calc, it has some int I, int j. The first thing is that if this cell was visited before, I mean I have been in here before, I just simply return res of ing because I know the answer already. So I will simply return res of ing if it's visited before. Also, there's one more thing that I have to say. There's one more thing. If I visit some cell again and the rest of the cell is not yet calculated, okay, so it means that I have started calculating this cell but I have not finished it, and while I'm calculating its value I'm coming back to this cell again. That means that I can just go through this cycle indefinitely, and the answer is inf in this case. So what do I mean? I mean that, for example, let's take a look at this second case where we have D, I, M, A. We start from, for example, here. We go to this cell because it's I. This is the only cell we can go next. And then we go here because that's the only cell we can go to. Then we go here, then we come here. We see that this cell D is visited, but its answer is not calculated yet. It means that we are not calculating the answer of this cell. While we are calculating it, we came back to it. So this cycle can be just done infinite number of times and the answer is infinite. So if some cell is visited and its res is not calculated, the answer is infinite. So what I do is this. I set 3 values for visited. Vis of I and j equal to 0 means that it's not visited. This cell is not visited yet. Not visited. Vis of I and j equal to 1, it means that it's visited, but res not calculated yet. Res not calculated yet. Equal to 2, it means that it's visited and the res is calculated. So we're done with it. Its value is calculated. So if we reached something that its vis was equal to the value of the visited of this cell was 2, it means that its result has been calculated, so we're in that. But if we reached somewhere that vis of I and j is equal to 1, it means that we visited this cell and we are still trying to calculate its result. We are not done with it yet. So we wanted to calculate the result of this, and we were to different cells and we came back here. So we can do these cycles indefinitely. So in this case, I will return inf. Or I can just say that just cout inf, cout pur ina, cout pur ina, and exit 0 to just finish the code. There was some problems. Let me load the page again. So cout pur dima and exit 0. Okay. And if after that, it means that after that we want to calculate the result of this cell. We want to say that vis of I and j is equal to 1. It means that we entered this cell and we want to calculate the value of this cell. Now we have to see the adjacent cells and consider the cells that have the character we want. Okay, what we can do is to just pass some c as well here, which means that which character are we looking for. Int of c means that which c is from 0 to 3. Are we if it's 0, it means that we're looking for d. If it's 1, it means that we're looking for I. If it's 2, it means that we're looking for m. If it's 3, it means that we're looking for a. I write a string here. I write string of s equal to dma here. And then this way I know that the next character that I'm looking for, its index is c plus 1 modulo 4, and the character itself is s of I dx. The character itself is s of I dx. So we know that what character we want. And then we consider the 4 cells that we have next to this cell, and for each one of them, if it had the character we are looking for, we will call that one. So there are different ways for that. I show that the cleanest way to do this, to call the 4 adjacent cells. You can do it with 4 ifs. For example, if this cell existed, just do that, do it 4 times, but it's not very neat. There's a neater way to do that. And then after that, after you just call the neighbors, you will just say that vis of I and j equal to 2. It means that its result is calculated. The result of the cell is calculated and it's close. I mean, we're done with this cell. Is it clear so far? If it's not, I will show you the code as well. Maybe let me first show you the code, the clean way of coding this, the code that got accepted on this problem. What I do is this. I first seen the cells in the table, and the rest of I and j is initially set to be -1. It means that the rest is not calculated yet. And then I have a 4 on all the cells. I see, whenever I see that I have some cell that its value is d, I will call a DFS on it. I mean, this can be also known as DFS, because basically this concept of investigating different cells and going through them is basically, it's like we are doing DFS. It's like we are doing it on a graph. DFS can be done on a table. I mean, a table by itself is like a graph as well. Like each cell has at most 4 adjacent cells. So it's like a node in a graph that has 4 adjacent nodes. So I say that if rest of I and j was not calculated, this means that if it's not equal to -1. I don't know why back then I was using this, but if this makes you confused, it just means that it's not -1. If rest of I and j is not -1, sorry, it is -1. This means that it's not -1 till the rest of I and j. That's because, I mean, -1 in base 2 has all bits equal to 1 till the flips all the bits to make it all 0. So if the number is -1, this would be false. Otherwise, it would be true. When you put a not before it, it means that if rest of I and j is equal to -1. If rest of I and j was equal to -1 and s of I and j is equal to d, you start DFS from this cell. And you say that ans equal to maximum of ans and rest of I and j. And at the end, you will see out ans. And what do we say in here? We say that if rest of x and y is being calculated in here, just return rest of x and y if it's been calculated. And otherwise, so if it's not -1, it means that it's calculated. Just return it. Otherwise, first set it to be 0. Now we want it to have real values. So initially it's 0. And then we keep that. What is the next character we're looking for? Is ch of c plus 1 modulo 4. Ch is this, the set of these characters, dima. So we know that what is the next character we're looking for. Then we have a 4 on the neighbors. How do I do this? I will have a 4 from 0 to 4. Let me know if any part was not clear. Yeah, I'm gonna talk about this right now. I mean, I'm exactly talking about how to implement this problem in a good way. So basically, I have a 4 from 0 to 4. I want to have a 4 on the neighbors. That's also something that you need to know for having, you know, in general, the problems that have DFS on a table, the cleanest way to implement them is like this. You can define two arrays, dx and dy, delta x and delta y. Set one of them. I mean, just say that each neighbor, what is the relative position of each neighbor compared to this cell. So the first one has one more x, but its y is equal. The second one has one less x, but its y is equal. The third one, its x is equal and its y is one more. And the fourth one, its x is equal and its y is one less. You have a for I from 0 to 4. You say that this neighbor, x of this neighbor, would be equal to x plus dx of I. Y of this neighbor will be equal to y plus dy of I. If you look at it, for example, if I is equal to 0, nx will be x plus 1, ny will be y. If I is equal to 1, nx will be x minus 1, ny will be y. If I is equal to 3, nx is x, ny is y plus 1. If I is equal to, that was 2. If I is equal to 3, nx is equal to x, ny is equal to y minus 1. So basically it's all these neighbors. And then you say that if it was not inside of the table, inside is this function that just checks if this cell is inside, it's not out of the borders. If it was not inside, or if it was not the character we were looking for, continue. Otherwise, if it was marked, just it means that we will see this cell indefinitely. I mean, we can create dima indefinitely because mark is set equal to 1 here when we are inside this cell, and when we are closing this, I mean, when we calculate its rest, we set it 0. So if mark is 1, it means that this is still open. We are calculating its value, and we came back to it while we were calculating its value. So mark is an indicator that shows that we are still calculating this value, and when we get back to it while calculating its value, it means that we have found an infinite cycle. And then we say that if this happened, the answer is infinite, otherwise rest of x and y is equal to maximum of rest of x and y and dfs of nx, ny and c plus 1 modulo 4. And at the end, if c was equal to 3, it means that if this cell had a in it, it means that a dima is completed. In that case, rest of x and y plus equal to 1. In that case, we will increase rest of x and y by 1, and we will return rest of x and y at the end. And this will give us the answer we want exactly. Is it completely clear or not? If it is, please use this emoji or put a plus. If it is not, also let me know if it is not clear for you guys. Good. If there are any questions about it, let me know. So you see that's how using simple recursive ideas we solved 2000 problems. Yeah, the difficulty of this problem was 2000 or 1900. Anyway, it's around 2000. The difficulty of this problem is 1900. So it's not a very simple problem. I mean, its rating is around a candidate master. But you see that the ideas were okay. So, I mean, we basically use the same ideas that we use for recursion. Make sure to accept this problem, guys. I mean, it is super helpful for you to solve a challenging problem like this. I want you to understand that it's not impossible to solve such problems. It is possible. You can accept these kind of problems as well. I want you to understand that it's not an impossible thing. Okay, if you need any further explanation, let me know. If not, you can maybe, and I have shifted so much to right. Yeah, now I'm good. Okay, guys, great. And guys, maybe let me tell you a little bit about the membership as well right now. If you want, you can join this channel from here. This is a great way to support this channel. I mean, as you know, and I also said in the Telegram channel, I never earned anything from this channel, and I'm still not planning to earn. But I spent more than $1,000, and there are some barriers to spend more money on it, and that limits the growth of the channel, because I'm trying to spend money on the video editor, streamers who do stream on the channel, the platforms. And I'm more than happy that I had the chance to do this. This YouTube channel is one of the best things that I've done in my life, and I'm really more than happy that I've done that, really. But I believe that this idea really helps the channel to grow further and remove some of the barriers that we have that stops us to create more content and greater quality content. If you support this, that definitely helps us a lot to grow and move on to the next level. And you can see that the prices are different. For example, this supporter tire is 99 cents in the US, but for example in India is 34 cents, and in different countries is different. So these are the US prices, but in different countries is different. The supporter tire is like this. You get the problem of the week. Each problem you will give, each week you will be given one of the best problems of Codeforces to solve. You will get these emojis to use in the chats, like ors, accepted, etc. You get a badge next to your name, and you can vote on topic streams every 2 weeks. One week it will be between anyone in the Telegram group. 1 week you can do it in the channel. And course discounts. It means that I will make sure that you get your own money back. I mean, the money that you spent here, you get that money back on the course discount, because you are creating that course possible. You are the one who making it possible. So you will be given this money back when I can create the courses. And the problem solver tire is just early access to new videos. It has more features. Early access to new videos, curated problem sets, a PDF that you will get each week, the problem set of that week, access to past member content, behind the scenes sneak peeks, and weekly contests on Codeforces Group. That's our members only. We also have public ones as well that you can participate in. And also Fast Learner, which is focused private live streams. I will try to add, we will have monthly live streams for this tire, and early access and having even higher discounts for the courses, because just again to make sure that you get your own money back at least, and monthly video by your choice, study plan of the month, and member shoutout. At the end of the videos, your name will be shown on the end screen so that everyone can see who made creating this possible. Because I'm starting to believe that if we didn't find a way, it's always possible to fail everything. Because there are a lot of barriers, and the thing is a lot more serious that we think at the beginning sometimes. And the future Grandmaster just said quickly, you will have a private Discord and Telegram group with me that we can talk in it, personal training plan, and milestone shoutouts. So when you reach I make sure that you will reach high ratings. And whenever you reach that, if you are okay with that, I will shout that out in the channel that you reached that level. Okay. So if you wanted, you can join this and support the channel, and that in response you will definitely get some perks as well, so that it would be more than valuable for you guys. If this channel is really helping you as much as a fraction of $1 per month, please consider joining and helping our community. If not, and you cannot do it for any reason, that's completely understandable, and there's no issues with that. Even the fact that you want to do this but you can't, that still means a lot. Yes, it's not too much. Exactly. I try to set the prices very low so that they won't be too much, so that there won't be pressure on anyone. But if a lot of people do that, we're gonna have a lot of power. So yes, the money is almost nothing. I mean, it's a fraction of $1. It's around half a dollar. If we take average in all the countries, it's like half a dollar. So it would be almost nothing for anyone. But if a lot of people do it, I believe that it can help a lot. Okay. Yes, I can, if you want, you know, my videos so far are about how to getting out of newbie. But if you want, I can create about how to pupil as well. There are some people who want me to create. Guys, the next video is being ready as well. Get ready for the next videos as well. The next video is getting ready and it will be released very soon. The fatal mistakes in competitive programming, and as I posted on Instagram as well. And thank you very much. Please wait. Okay, let's talk about the next problem as well. Not wasting time. The next problem is ice cave. 540C. We will talk about that, Aditya. Yes, that's totally okay. Whatever your current rating is, I believe that you should continue solving more problems on that current rating. Usually, to be honest, after solving these many problems, you can get out of newbie, but they sometimes happen as well, that sometimes maybe you're not lucky on the contest, or maybe you get anxiety, you get stress on the contests, and that might be problematic for you. Don't lose your hope. I believe that, okay, continue solving more problems. Maybe you should put more efforts right now because of the issues that you have with participating in contests. I see. That's totally okay. That happens to a lot of people. There were a lot of people that this happens for them at the moment. So, but it's okay. I mean, I've seen a lot of people that had some issues at the beginning, but once they started growing up, they could go further above and the rating increased further. You should not, I believe that if you really want to stay in the field, you should not lose your hope so quickly. Okay, I will talk more about it. And yeah, you can watch the next video very soon as well about fatal mistakes in competitive programming and see that maybe you're making some of those fatal mistakes. Maybe the reason that you are not growing that much is making those fatal mistakes. Yes, we can even have a topic stream on that in the future. Nice, Hamza. That's an example of dedication. That really means a lot. Bravo. Well done. Okay. Let's move on to the next problem. I send its link again. Each time that I come and send the link, I see a new message and I try to respond that, and we spent 10-15 more minutes in the chat. So I just sent the link here. Sorry, the guys who are sending messages right now. Let me start talking about the next problem now. That says you play a computer game, your character needs on some level of multi-level ice cave. The point is that you have an ice cave and it's a rectangular square grid of n rows and m columns. It's a rectangular grid of n rows and m columns. Each cell consists either from intact or from cracked ice. Some cells are intact, they are shown with dots. Some cells are cracked, they're shown with crosses. And from each cell you can move to the cells that are side adjacent with yours, and you cannot stay at the same place. Each time from each cell you should go to one of the adjacent cells. And if you move to the cell with cracked ice, then your character will fall through it, and if you move to a cell with intact ice, then that ice will get cracked. So if it is intact, when you move on that, it gets cracked. If it is cracked, when you move on that, it falls down. And let's number the rows with integers from 1 to n from top to bottom, and the columns from 1 to n from left to right. You are staying in the cell R1 and C1, and you want to fall down through the cell R2 and C2. You want to fall down exactly from cell R2 and C2, since the exit is there. How can you do this or not? You should just return yes or no. Can you do that or not? For example, in this example, if you start from 1 and 6 and you want to go to 2 and 2, you will start from here. This cell is always cracked. This cell R1 and C1 is always cracked because you start from that one, it's going to be cracked. You can come here in this path and all of these get cracked, and you can reach here this way. And after that, when this one is cracked, you can then move on to this one and get this one cracked as well, and then come back here. Then this one was cracked from the previous time. This second time you will fall down from this cell. But from here you cannot do this. If you start from 5 and 3, which is here, and you want to go to 1 and 1, you can come to 1 and 1. But it will be cracked and you cannot fall down from here. Because if you go to any of these neighbors and want to come back, in the first time that you go to any of the neighbors, that's what you will fall down from there. So the answer is no here. Is the problem statement completely clear, or are there any issues with the problem statements? Great dedication, Sean. That's really great. Bravo. Yes, sure. So basically it says that we have a table of size n by m. Each cell of this table has either an intact ice or a cracked ice. When we go on a cell, if it is intact, it gets cracked. If it is cracked, you will fall down from there. And you start from cell R1 and C1, and you want to fall down from cell R2 and C2. You want to find out if that's possible or not. So you want to fall down from cell R2 and C2. So if it is not cracked, you have to first crack it and then go back somewhere and then come back to here to fall down from here. Or if it is cracked already, you can just go there. You have to say that, can you do this or not? Is it clear now, or okay, nice. Okay, good. So, hi Bimo. So, okay, let's see that what we can say. I will explain it on my code because that's a very simple code. Guys, what we do is this, and this is the accepted code of this problem. What we do is this, we get the row and the column of the cell, and we say that we put S of R and R1 and C1, we set it as a dot. And then we say that if these 2 points were equal, is the point of. The point is, I'm just using point as a pair of int and int. A point means a pair of int and int. Just to make it simpler, I haven't defined a struct. I just said that use point as pair of int and int. If point of R1 and C1 was equal to point of R2 and C2, if they were the same, it means that it should have at least one adjacent cell. Because it is cracked right now, you should have an adjacent cell to go there and then come back here so that you can fall down from here. So if it has an adjacent cells, if deg of R1 and C1 was non-zero, the answer is yes. Otherwise, the answer is no. Okay, so if they were the same, the answer is yes if and only if the degree of this cell is non-zero. It has at least one adjacent cell, and degree is calculated like this. You have a 4. You see exactly the same way of having a 4 on the neighbors. You have a 4 on the neighbors, and you say that res plus equal to, it should be inside first, and then after that it was inside. This cell must be equal to dots. So now you say that if degree of R2 and C2 plus S of R2 and C2 equal to X was less than 2. What does it mean? To simplify it, it means that if this one was equal to dots, it should have at least 2 neighbors. One neighbor that we go to this cell using that neighbor, and another neighbor that next time we go to that one. Let's switch to the tablets. Well, if this is R2 and C2, I say that assume that it's a dot here. It should have at least 2 neighbors, so that first we can go to this cell using one of these neighbors, and the second time we can exit it to another neighbor and come back. This way, the first time it gets cracked, and then we will have another neighbor too. Then we will move to that other neighbor and come back, and this will be we can fall down from here. And if it is cracked, it should just have one neighbor. One neighbor is enough. It doesn't need 2 neighbors. So how I implemented it was this. I said that if S of R2 and C2 equal to X, this is either 0 or 1. If it is dot, this is 0. If it is X, it is 1. Plus the degree. If this was less than 2, the answer is definitely no. Because it means that either it's dot and degree is less than 2, or it's X and degree is less than 1, degree is 0. In both cases, there's no way. Otherwise, I set visa of R1 and C1 equal to 1, and I start a DFS from C1 and R1 and C1. I show that if these conditions were satisfied, the only thing that we need to make sure is that there's a path from R1 and C1 to R2 and C2. Why? Because basically this having cracked eyes only means that we can visit each cell at most once. Each cell can be visited at most once. If a cell is cracked, you should not visit it at all. Because if you visit it, you will fall down from there. All the cells except R2 and C2, if they are cracked, you should not visit them. If they're not cracked, you should visit them at most once. So it means that, is there a path using these dots from R1 and C1 to R2 and C2 or not? Is there a path using the dots from R1 and C1 to R2 and C2 or not? If there is, we can simply go there. And if this cell was a dot as well, we know that it has another adjacent cell as well. We will go there and come back, and we will fall down from here. And if it was an X here, we already fall down the first time we come here. So the problem will get reduced to, do we have a path from R1 and C1 to R2 and C2 using dots or not? The problem will get reduced to this. So basically in my DFS, I do the same thing. I just have a 4. I will consider all the cells, and I say that if it was inside and it was not visited, I will set visited equal to true. And if it was equal to dots, I will run the DFS from there. If it was a dot, it means that I can go there too. So I will consider that one. I see that if there is a path, if at the end R2 and C2 will be visited or not, if there's a path to R2 and C2 or not. If there was, if it reached R2 and C2, I will see out yes. Otherwise, I will see out no. And this will give me my final answer. Is this clear? Is dx and dy differential of dx is differential of x, dy is differential of y, basically. So dx means that how the neighbors have different x's compared to this one relative to this one. Dy means that how the neighbors have different y's compared to this one. So basically it means that in here, the first neighbor, when I is equal to 0, this is x plus 1 and y. When I is 1, this is x minus 1 and y. When I is 2, it is x and y plus 1. When it is 3, it is x and y minus 1. So it's basically all the neighbors. And we see that if it was a dot, we can go there. Is it completely clear? Okay, if you guys have any questions about it, let me know. Otherwise, I will quickly talk about the last problem as well. So far we have solved the 2000 rated problem and the 1900 rated problem. Two problems with difficulty around 2000 are solved. And now we want to solve the third one. What are dx and dy? Dx and dy is, basically what we want to do is to have a 4 on the neighbors of this cell. We have a cell. We want to find the neighbors of this cell. So what we do is this. We have a 4 from 0 to 4. What happens when I is 0? What happens when I is 0? The dx of I is 1. dy of I is 0. So x plus dx of I and y plus dy of I means that x plus 1 and y. So it's the first neighbor, x plus 1 and y. When I is equal to 1, dx of I is minus 1, dy of I is 0. So this is x minus 1 and y. When I is 2, this is x and y plus 1. When I is 3, it's x and y minus 1. So basically we're having a 4 on all the neighbors of x and y. Is it clear, near it? Or if anything is not clear, let me know to explain it again. So basically the idea behind dx and dy is to have a 4 on all these neighbors. We don't want to use several ifs, several different ifs. What we want to do instead is to just have a 4 on these neighbors. That's what we want to do. Is it clear? If it's not, let me know. Otherwise, let's move on. So we have a 4 on all these, and at the end we just showed that it's enough to find out if there's a path from R1 and C1 to R2 and C2 using these dots or not. If there was, the answer is yes, otherwise the answer is no. And do not forget that if S of R2 and C2 is a dot, this cell should have at least 2 adjacent cells. Otherwise it's enough to have 1 adjacent cell. When you explain, I understand it well, but I face a lot of difficulty when trying to do it on my own. Yes, that's okay. Just try to understand it well in the topic stream, and then after that make sure to implement it. This way in your brain, your brain gets trained to understand these patterns of solving problems. So that's really important. Understand it well in the topic stream, and then after that try to accept it. Make sure to accept this problem as well. This will help your brain to train solving these problems and getting familiar with the ideas. Okay. Let's move on to the last problem as well, if there are no problems with this problem. The next problem is 1746D. Path on the tree. It says that you are given a rooted tree consisting of n vertices. The vertices are numbered from 1 to n, and the root is the vertex 1. You are also given a score array S1, S2 to Sn. A multiset of k simple passes, a multiset of k simple path is called valid if the following two conditions are both true. Each path starts from 1. Let C sub I be the number of paths covering vertex I for each pair of vertices u and v that have the same parent C sub u minus C sub v less than or equal to 1 holds. So basically, we have a rooted tree of n vertices. You start from vertex number 1, which is the root. You have several paths from vertex 1 downward. You have several paths. And you want to make sure that for each two vertices, u and v, that have the same parents, the number of path that passes over this vertices differs by at most 1. If Ci is the number of paths covering vertex I, Cu minus Cv must be at most 1 for each two brothers, each two siblings, pair of vertices u and v that they have the same parents. The value of the path multiset is defined as sigma of I from 1 to n Ci Si. And it can be shown that it is always possible to find at least one valid multiset. Find the maximum value among all valid sub multisets. So each vertex has a score, and for each vertex you see that in how many paths it is covered, and you will multiply that by the score of this vertex, and the sum of these values is going to be the total score of our tree. You have to say that what is the maximum value, maximum score that we can get at the end. Oh my god, I didn't see that. Yes, sorry. I hope that you have opened the statements by yourselves. Otherwise you didn't see anything. Yeah, I was on this tab, not on this tab, so I didn't see your messages. So I will say it very quickly again to make sure that you understood it well. You are given a rooted tree consisting of n vertices. The vertices are number 1 to n, and each vertex has a score, S1, S2 to Sn. A multiset of k simple path is called valid if the following two conditions are both true. Each path should start from the root, vertex 1. The path starts from the root and go downward. For each two siblings, vertices u and v, that they have the same parent, C sub u minus C sub v must be at most 1. You have to find the value of the path multiset, that is sigma of Ci times Si. For each vertex, you see that how many times it appears in the path, and you see that what is the score. We multiply these two numbers and sum this up for all the vertices. And it can be shown that it is always possible to find at least one valid multiset. Find the maximum value among all valid multisets. Is it clear? Is the statement clear or not? If you didn't understand it well, especially because we didn't have whiteboards, we didn't have the screen, let me know to explain it again. If you understood it well, put a plus or use this emoji again so that I know you understood it, so that you can confirm that you understood it and I can continue. Let me know if there was any issues. Okay, so I guess there are no issues. I will quickly explain this as well, so that make sure that you understood it. So basically, in this problem, first of all, you can say that each path will be from the root to one of the leaves, because if it's not up to a leaf, it means that you could extend this path. And there's always a way to extend one of these paths, as considering that SIs are non-negative. It never harms to add more vertices to a path. You could always find one vertex that you could extend this path using that vertex. If you consider from each vertex, assume that you have a path that ends in here, and it still had children, but you are not adding them to the path. So this path is not ending at a leaf. You could consider the minimum child, the child that has appeared in the minimum number of paths, and extend it from that vertex and add this vertex to the path as well. So you could add this to the path and the answer wouldn't get worse. So always you could extend them. So, and you can say that there exists an optimal answer that all the paths are from the root to one of the leaves. All the paths. And now you want to find the maximum value. You can easily say that if a vertex has appeared in K path and it has C children, some of the children of it will have the sailing of K over C will be appeared, considering the fact that all of them will be extended to the children. Some of the children will be appear in the sailing of K over C paths. Some of them will appear in the floor of K over C paths. And you can find out that exactly how many of them are sailing, how many of them are floor. Exactly K modulo C of them will appear in the sailing of K over C. K minus K modulo C of them will appear in the floor of K over C. And you can easily calculate this value. How? Let me show you the codes that is here in the editorial of this problem. Let me show it to you. 1746D. This helps you understand it a lot better. You know, in here we will see that we will store for each answer, we will keep, for each vertex, we will keep the answers for different values of K. We are using Backtrack to calculate these DPs. We are using Backtrack, Recursion to calculate these DPs. We start from here and we say solve, and we get the inputs and seeing the parents of the vertices and start solving DP of 0 and K. It means that we're at the roots. It's 0 based. They have changed this. They subtract 1 from the dash, so it would be 0 based. They will calculate DP of 0 and K, starting from the root and their K paths here. In each vertex, you have to find out if K is equal. You have a 4 on the answers of this one, and there's a pair. It says that for which K, what is the answer? Okay. So in this vector, if K is equal to KP, you will return the answer. In the answers, you keep the pair of the K and answer for this K. And then you see that how many children you have, and ans will be added by K times V times V. K times V of V, V sub V. If CNT of child was equal to 0, you will return that right away. Okay, the answer is K times V of V. Otherwise, if K modulo CNT of child was 0, you will have a 4 on all the children, and you will say that ans plus equal to dp of u and K over CNT child. Because if CNT child is 0, all of them should get equal number of paths. Let me check the chat. Temporal, is it? Yeah. I can only solve 800, only 1200. I will talk about that. Make sure to watch those guideline videos that you can find in the channel. It's really important. If I say it again, I will again repeat the same things that I said in that video. Make sure to watch it. That's super important to watch those videos. Okay, and then I say that I have dp1, dp2, and dp of CNT of child. What does this do? I say that, okay, each one of the children will get either floor of K over the number of children or sailing of K over the number of children. First, I see that I calculate that what are these values. dp1 of I will be dp of child of V and I, and K over CNT of K over CNT of child. dp2 will be K over CNT child plus 1, the sailing of K over CNT of child. So I see that what is their dp if they get floor of K over CNT child what if their DP if they get the sailing of K over CNT child? And I see that what is the difference between these two? How much if they get one more path, the answer will improve. And then I give DP1 to everyone, I give the floor of that value to everyone, and then I will have another floor and consider the first ones that they get the best improvement if I had one more path to them. So I will have a 4 from 0 to K modulo CNT child. It is sorted by their values. Starting from the greatest value is sorted in descending order. I start from that and I will consider the first K over CNT of child vertices, and I will add that difference to the answer. And I will, at the end, I will set, push back in the answer of V, the pair of K and S. And this will give me the final values, the final answers. This way, at the end, I will have the value of DP and 0 as my final answer. Is this clear completely? Do not forget that the limits are up to n up to 10 to the 5th and k up to 10 to the 9, and so the sum of n over all test cases is up to 2 times 10 to the 5th. This was another 1900s problem that we had in this contest, and this one could also be solved with backtrack, recursion, and memoization. This is harder than the rest, though, because it includes DP. Yeah, maybe. Can you share the submission link? This is the editorial. It's the problem D of editorial. How to determine if it is possible to visit all unvisited cells without visiting any of the visited cells where you can only move to an adjacent cell. You are also given position of without visiting any of the visited cells there you can only move to an adjacent cell. Okay, so what you want here, Shohanur, is a Hamiltonian path, based on what I understand. You want a Hamiltonian path. A Hamiltonian path is a simple path that visits all the vertices. Okay, a Hamiltonian path is a path that visits all the vertices. And this is an MP problem. There's no polynomial problem for this problem for now. Any tips for reaching CM from experts? I highly recommend you to participate in virtual contests and of solving them. That's super helpful. When I was expert myself and I wanted to reach candidate master, I was doing virtual contests and of solving them. I mean, after that, after the virtual contest, I was reading people's codes for the problems that I thought but couldn't solve during the contest and implement that afterwards. That helped me improve a lot for myself. If you want, I can go into that in more detail in my next videos. And if everything is fine, I think now the time reaches to when I should leave as well. I hope that you have enjoyed the topic stream. If you have any final questions, feel free to ask me your questions. Otherwise, we can end the topic stream. Can you share some resources to learn these algorithms, please? Which algorithms do you mean? I can definitely share some resources, but I want to know that which algorithms do you mean. Thank you, Nairit. Thank you, guys. Thank you all the guys who supported, and it definitely means a lot to me. Thank you again. Okay. Can you make problem set of DP? Yes, definitely. If you look at the perks that I added to the memberships, that was a part of it. If you look at the tires, if you just click the join button in here, one of the things that I added was this, adding the problem set. Yeah, bro. The stream is ending. You came a little bit late. But don't worry, you can watch the recording. Algorithms which are used in maximum question. Yeah, okay, yeah. I can, like, if you mean maximizing questions, yeah, sure. If you maximize searching. You're welcome, Parik shit. Namlev. Nairit strategy. If it's possible, can you tell us where to study graph and trees? I'm weak in these topics. Yes, definitely. I will totally recommend to you at first to watch the topic streams. In there, I talked in detail about these topics that you're asking about graphs. Just open the playlist of the topic streams and start watching the ones on graphs, on graph algorithms. That's where I talked about these topics in detail. Tell how to do advanced DP and graphs. First, watch the topic streams if you haven't done that yet. And then maybe in the next topic stream we can deep dive into these topics. You can share the names I can learn from YouTuber blogs. Thanks. Definitely. Okay, sure. I will. And if you want, even the topic streams can be on these topics as well. Especially about minimax algorithms that use binary search. If you watch the last topic stream, you see a problem like that as well. Any geometry stream in the future? I don't think geometry is that important. I personally never liked geometry as well. And it's not really that important as well. But if you really want it, I can do a geometry stream. If I can put it in the votes. Let's see, that's what you decide. There's no option of UPI to join the channel. I only have UPI. How do I join? What is UPI? Let me search. I don't know what is UPI. Online payments. There's no way to use online payments? How is that so? There is. Oh, without debits and credit cards. I'm not sure about that. Maybe check that. I'm not sure about that. Does doing competitive programming help for HFTs and quants too, or is it a totally different domain? If yes, please explain. Definitely. In quant, there are a lot of competitive programmers in quants. There's a lot. I mean, that is getting a lot more common right now for competitive programmers to get into quants. You can also watch my interview with Arash Mahmoudian here. Let me edit it. This is starting from the middle of interview. Click on this link. Arash Mahmoudian was one of the people who works in quants, and he's earning a lot of money, even way more than this, maybe more than 800,000 per year. It's okay, anonymous. That's completely okay. I mean, even the fact that you wanted to join that means a lot to me. Okay, no problem. Thank you guys. Thank you very much. Okay. No problems. Okay. Thank you, Agolberto Sanchez. Thank you very much. I hope that you enjoyed it. And Alok Money, thank you very much. Thank you very much for your support. It means really a lot to me. And I believe that if a lot of people join this, we can really get this YouTube channel to the next level and make it a lot better than what it was. And we can even make, I mean, my ideal goal is to bring the education of competitive programming to the next level. And I think that we are now gaining that power together. I cannot do it alone, but together I think that we are gaining this power to change this. Great. See you guys next time. And thank you for joining. Bye bye.